Okay guys, welcome back. This is Itsu again. As promised, some testing with serial resonance. You're looking now at the scope which shows the circuit now in serial resonance. The red curve is again the current across a 1 ohm resistor, and the yellow is the voltage across the coil, and you again see that it's perfectly in 19 degrees shift. The current is lagging behind. I had to increase the frequency a little bit, 160 around, to get this equal shot. The only thing I had to do is to get this perfect scope shot is to make a short. And when we go to the circuit that I'm using at the moment, I only use one coil per at the moment here. This is my 40 microfarad capacitor I used also for parallel. And this is my 1 ohm resistor I'm measuring the current across. But to get this perfect sine wave, I have to make a short here, so before the full bridge rectifier. If I make the short here, like suggested by Bolt, then I have a much more distorted picture. I will do that now. I will remove the short from before the bridge and put it behind the bridge. And you can see that well, we're pulling out of resonance now. I have to slow down the rotor a little bit, around 160. I'm doing it by hand now at the moment. And you can see that the voltage is a little bit cramped, and it's not that nice sine wave as with the short before the full bridge. And it's going faster. So that's one of my observations, that the serial resonance has some distorted pictures on the voltage if I put the short behind the full bridge rectifier. Okay, well, again, the scope shot from a short circuit behind the full bridge rectifier. When I remove the short and running basically with no load, which I will do now, you can see the scope shot and you can hear the RPM going up very fast. Okay, it's now disconnected, and I'm now back to a normal kind of waveform for the backnet without any current. Put it a little bit lower. This is the normal waveform I would expect without being in resonance. And looking at the frequency, we are way up, so we are way out of the resonance frequency. I can slow down the rotor now, put it back to the resonant frequency of about 150 Hertz. But you can see the waveform does not return to a perfect sine wave. And we are in resonance now, series resonance. So I'm a little bit puzzled about it. We have now an open circuit behind the rectifier, and we can see the DC voltage when I attach the cap, and I have a load of about 28 LEDs on it. So I'll put now a load on the thing. LEDs are lit. It's a brake light LED. Voltage is about 7 volt. And this is the scope shot from both the current and the voltage. I'll try to adjust a little bit stable. And you can see that we are in phase. The voltage and the current are in phase now. But still we are way high in frequency. I can slow it down, but it won't return into the resonance state, the sine wave. So there's a huge difference between running in parallel and running in series. Again, the 7 voltage DC on the cap. I have all the LEDs, the brake light via this cap. So I'm not sure what to think about it. I see no evidence of speeding up under load like it does in parallel resonance. So I have to think about this, what this has for consequences for running this rig.